Lesson 6-7, midpoint of a line segment. And in this lesson, you learn to find the coordinates of a midpoint of a line segment and a coordinate plane. Why is it important? Because you can find the midpoint of a line segment to solve problems involving geometry. Let's take a look at this real-world application in woodworking. Maria Hernandez made a frame for one of her watercolor paintings in a class offered at the community college. Her instructor suggested that she stabilize her frame by adding crossbars connecting the consecutive sides. One of the books she used as reference showed the crossbars inserted so that the bars are placed on the sides of the frame at the midpoint of each side. Okay, the midpoint of a line is a segment. A segment is the point that is halfway between the endpoints of the segment. So basically, this is what it's saying. This is your midpoint, and that's where she attached the bars to make it stronger. Okay, so Maria decided to use some grid paper to model her frame and the crossbars she is going to insert. Each square of the paper represented 2 inches of the frame. Okay. To find the midpoint of the interior vertical edge, she counted how many units it was from one corner to the next and divided by 2. So basically, she counted the number of units from end to end and divided by 2. Okay? The inside of the frame is 16 inches high, so the midpoint is 8 inches from the corner. She counted 4 units on the grid paper and placed a bullet on her drawing. She used a similar method to find the midpoint of the interior horizontal edge. The inside is 20 inches wide, so the midpoint is 10 inches from the end. Okay, so suppose we place Maria's frame drawing on a coordinate plane. Let's list the coordinates of the corners of the frame and the midpoints of the sides. Okay, something like this. And what pattern do you notice? Okay, so if A is 2, 2, okay, and B is 22, 2, right there. Point C is 22, 18, and point D is 2, 18. Okay, the midpoint of segment AB, okay, this one right here is that point right over there, which is 12, 2. The midpoint of segment BC, right there, is that point right over there, which is 22, 10. The midpoint of segment CD up there is going to be 12, 18, and the midpoint of segment AD down here would be 2 and 10. Okay, so look at this carefully and let's analyze what we have. Notice that the coordinates of the midpoint AB right here are the mean of the corresponding coordinates of A and B. Okay, that means of point A and point B. So the midpoint of segment AB is 12, 2, which means that 12 is the mean of the x coordinates of point A 2, 2 and point B 22, 2. Okay, which means you simply add 2 plus 22 together, right there. Okay, and then divide that by 2, and that's how you got 12 as your midpoint of, or the x-coordinate of the midpoint of segment AB. And 2 is the same thing. The mean of coordinates, again, point A 2, 2 and point B 22, 2. Or you're simply adding 2 plus 2 and dividing it by 2, which is equal to 2. Okay? So this woodworking example uses the midpoints of the horizontal and vertical line segments. Okay? The modeling mathematics activity on the next page applies to any line segment. But I guess we're not doing the modeling mathematical activity, and we'll move ahead to the definition of a midpoint. Okay, midpoint of a line segment on a coordinate plane is this. The coordinates of the midpoint of a line segment whose endpoints are x sub 1, y sub 1, and x sub 2, y sub 2 are given as, okay, an ordered pair. This is an ordered pair where the x-coordinate is x sub 1 plus x sub 2 all over 2, and the y-coordinate is y sub 1 plus y sub 2 all over 2. Okay, let's take a look at how this works. Midpoint formula. if the vertices of a parallelogram w, x, y, z are 30, point w is 30, point x 93, point y 710, and point z 17, prove that the diagonals bisect each other. That is, prove that they intersect at their endpoints. Remember, in 6th grade we talked about bisecting line segments, and when you say bisect, okay, a line bisects along the segment at their midpoints. Okay, so we want to prove that they intersect at their midpoints right there. Okay, let's see. Graph the vertices and draw the parallelogram and its diagonals. So you have these are your vertices, and these are the diagonals. Okay, find the coordinates of the endpoints of the diagonals to see if they are the same point. Okay, and then find the midpoints of WZ right here, segment WY, and segment XZ. So we want to find the midpoints of those two. Okay, so first we get point W, okay, x sub 1 as our x sub 1 side, y sub 1, which is in this case W is equal to 30. It lies on the x-axis. Okay, and our point X would be x sub 1, y sub 1, 93. Our point Z is 17, and finally our point Y will be 710. Okay, so first we want to find out the midpoint of segment WZ. So that means we need to apply the midpoint formula to be able to find out the midpoint. Okay, so using the midpoint formula of segment WY, you get your x sub 1 plus x sub 2, okay, 3 plus 7 divided by 2, and 0 plus 10 all over 2 for our y coordinate. We end up with 10 over 2, 10 over 2, or the midpoint of segment WY would be 5, 5. So that is 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, and there you go, 5, 5 right there. Okay, and let's find out if we have the same midpoint for segment XZ. Okay, again, using the midpoint formula, we add 9 plus 1 divided by 2 and 3 plus 7 divided by 2. So you end up with 10 over 2, and if you notice, it's also 5, 5. Okay, since the midpoint of segment XZ has the same coordinates as the midpoint of segment WY, the diagonals bisect each other. Okay, so that is example number 1, and let's take a look at example number 2, and let's see another situation. So if you know the midpoint of one endpoint of a segment, you can find the other endpoint. Okay, so let's take a look at this example. The center of the circle, point M, 0, 2, and the endpoint of its radii, point A, negative 6, 4, negative 6, and negative 4. Okay, if segment AB is the diameter of the circle, what are the coordinates of B? So basically, this is the diagram right here, and this is the situation. You have the center of a circle, which is 0, 2, and the endpoint of one of its radii, which is negative 6, negative 4. So we know the midpoint, we know the one of the endpoints of this radii, okay, but we want to find out the other end right here. So we want to find out that end all the way to that end. Okay, so if segment AB, let's say this is B right there, if segment AB is the diameter of the circle, okay, what are the coordinates of B? So we want to find out the coordinates of B. Now this is if you look at this very carefully, you can find it right away by just looking at 6 and 8. But if you move the circle in a way, if the problem is moved in such that you cannot readily see the coordinates of B, then you need to do the procedure that we are going to do right now. So first, use the midpoint formula and substitute the values that you know. This is our midpoint formula. Okay, ordered pair xy is equal to x sub 1 plus x sub 2 all over 2, y sub 1 plus y sub 2 all over 2. Okay, and then we know what the midpoint is, which is 0, 2. Okay, and we know a, which is -6, -4. Okay, before we continue with this problem, if you notice, the midpoint is capital M. Remember when we started discussing slope? Slope is, okay, lowercase m, okay, and midpoint is capital M. So do not confuse the two letters, okay, capital M and lowercase m. Okay, going back here. So we have our midpoint, which is 0, 2. We are going to substitute 0, 2 to our x and y, and we're going to substitute -6, -4 in this case, okay, to we're going to substitute it to x sub 1 for -6 and y sub 2. Let me redo that again. Erase. Okay, so we are going to substitute -6 for x sub 1. I'm not cloning anything. And then we are going to substitute -4 to y sub 2. Okay, so we'll do that. 0, 2. Okay, -6 plus x sub 2 all over 2, -4 plus y sub 2 all over 2. Okay, and then from there, okay, we simply, okay, start equating our x coordinates and y coordinates. So we want to equate, okay, our x coordinate with that x coordinate and our y coordinate with that y coordinate. Okay, the x and y coordinates of the ordered pairs are equal. Since the ordered pairs are equal, okay, so the x and y coordinates of the ordered pairs are equal since the ordered pairs are equal. So the two equations can be formed. So like what we talked about, we are going to equate 0 with that expression, or x coordinate to x coordinate and y coordinate to y coordinate. So to be able to find the x coordinate, we equate 0 equals -6 plus x sub 2 all over 2. And using proportions, we have 0 equals -6 plus x sub 2 because we multiplied both sides by 2. And then we add both sides by 6. X sub 2 is equal to 6. Okay, and finding the y coordinate, we have now 2, because that's 2, equals -4 plus y sub 2 all over 2. Using proportions, we do cross products. That becomes 4 equals -4 plus y sub 2. Add 4 to both sides, you end up with y sub 2 is equal to 8. Okay, so in this case, the coordinates of the endpoints of the endpoint B, x sub 2, y sub 2, will be equal to 6 and 8, just as we thought. Okay, and if you want to check our answer, copy the graph of the circle and the points A and M, extend the radius through M and to intersect the circle. This segment is the diameter of the circle. The intersection point is at 6, 8, which are the coordinates of point B. Okay, now again, what I'm saying is this. Okay, you might ask, why do we need to go through all that if we can just read it from here? Because sometimes you're going to end up with a circle that looks something like this. If your circle looks something like this, okay, and it doesn't necessarily fall, okay, like this, for example, let's do it like that, and let's do or read the line here. Okay, and if you look at this carefully, and if this becomes now the radius of my circle, okay, you notice that it will not fall on a point where you can read it readily. Okay, so that's the reason why you go through that process. Okay, so let's get rid of that before we get confused. Okay, and that is the end of our lesson. Before we go, the secret word for this one would be square. The secret word for this lesson is square. Thank you for watching.